So you want to do the same thing we've been doing with the reducing of the fractions and continue to do that. Just recall that when you're adding, subtracting fractions, you need a common denominator. Everything today has a common denominator, but starting tomorrow, you got to make sure that these are the same. Now, there are some that are not exactly the same. They have to factor out a negative, like number 2 and 6 on the homework, and I'll go over those in a second. But first, just review that if the denominator is the same, you just add or subtract the top. Okay, so I'm going to write everything out. Now, you wouldn't necessarily write this kind of step out yourselves, but this would be the full, if you're going to show the full thing, this is what it would look like. Write it as a single denominator with just the numerators added or subtracted. Simplify the numerator any way possible by adding or subtracting. And then, like you guys did the past 2 days, you would factor the top and bottom and see what cancels. Now, here's where you would probably not really do this, but this is technically what you are doing when you're reducing a fraction. Right? You factor the top. 8 is 1 times 8, 16 is 2 times 8, and then anything that is the same will divide and equal 1. And that's how we get an answer of 1/2, because 1/2 times 1 is 1/2. Okay? And this is what you're going to be doing on your problems today, just with polynomials. You'll add the tops together, denominators will be the same, then you'll have to reduce it. So from this point on is really review from the past few days. How to reduce the polynomials, what we just practiced for 2 days. So if you're up to date with that, most of this, as you can see, will be review. If not, it'll feel like twice as much. Okay? As usual, if you have 2 negatives, minus a -5, that's the same as addition. So those rules still apply. Not that you'd write all these out, but this is how you'd show all the work. 12 divided by 12 is 1. And of course, if there's nothing left on the top, it's use a 1. If nothing on the bottom, you don't need to write anything. All right. And lastly, we have 11 minus 6 all over 25. 11 minus 6 is just 5. All right. So 5 into 25 is what? Is it 5? Yeah, 1 over 5. So if you cancel everything on the top, remember 5 divided by 5 does equal 1. So that's why our answer is 1/5. So I pointed that out just because some people will see a 5 and 25 and say, well, you're dividing. The answer is 5. The answer is 1/5. 1 over 5. So it matters where that 25 is. It's not the same if you reverse it. Just like subtraction, 6 minus 11 is not 11 minus 6. 5 divided by 25 is not 25 divided by 5. Order matters with subtraction and division. So let's do the same thing, but with the polynomials. Again, this will be the new part, just kind of simplifying it here, adding, subtracting, right? And then all of this will be what we just did the past few days, reducing it, simplifying it. And then we're also going to graph it, which is review from last week, the first quiz. So it has a little bit of everything. Now they do mention excluded values. For us today, because they're the same denominator, it's going to be the same thing as replaceable discontinuity. So just where we had that circle and the open circle thing, or the asymptotes. So it'll be one and the same. So same denominators. So I'm just going to write this and show all the same steps I did on the all numbers problems. Right? Adding the tops together. All over the same denominator. Now you might look at this and say, well, I know I can factor the bottom. Hold off on that. Do all the factoring and all that stuff at the very end. Let's simplify the whole fraction first and then start factoring. So we have x squared plus 3x squared which equals 4x squared. We have -3 and -1, which is -4. Right? So you can see I'm just combining like terms. They have the same exponent and variable. And of course, the denominator is identical. So that's it. That's as far as you can go for the new part. You can't add, subtract anything else. So then, just like we did above, as soon as we got it all written as one fraction, 8/16, you start factoring the top and factoring the bottom to see what cancels. So it turns into a review problem. So factor the top. You can see 4 goes into both, so take out a GCF of 4. And if you're not quite sure, you can always multiply these back. 4 times x squared equals 4x squared. 4 times -1 equals -4. And you'll know you're on the right track. If ever you multiply back together and it doesn't equal what you have above, then something's off. And the bottom has a GCF. 2 goes into both of these. So we'll have x plus 1. Now, can you factor anything more? Yeah, so don't start canceling. Keep going until you have factored everything. So the top here, probably noticed it already. Right, that x plus 1 can be, x squared minus 1 can be factored to x plus 1 times x minus 1. And we had a whole Khan Academy just on how to factor these difference of squares. So if we've caught up on and stayed current on all the homework, this is mostly review. So now everything is factored, and go ahead and just cancel whatever's the same on top and bottom. Now right here, I'm going to cancel a factor with a variable top and bottom. So because of that, I'm going to get that replaceable discontinuity, that open circle at x equals what number? -1. The value that makes this 0. And this whole thing exists because you cannot divide by 0. And if I put a -1 down here, I'm going to have 2 times 0, which is 0, and I can't divide by 0. And that's why we have these. Anytime they cancel out, we get a replaceable discontinuity. Or if it's just on the bottom, it turns into a vertical asymptote. Right, so we can also cancel out these numbers. 2 goes into 4 2 times, and then our answer will be 2 times x minus 1. Now, what kind of graph is this, and how can you tell? That's a straight line, and how can you tell? Because, yeah, there's only an x. There's no x squared or x cubed. We're not dividing by x. So to the first power, that's a linear equation. And of course, we're not used to graphing in this format. We usually graph in y equals mx plus b format with no parentheses. So just distribute this out. That way you'll have the slope and the y-intercept, and you can go ahead and graph. All right, so once I got, to this point, see, all this was review. Just very little bit is new, and really it's not that new because we already knew how to add a fraction in the first place when we already knew how to combine like terms in the first place. So it's just a lot of different concepts all together. It's just like right here, we had 8/16, reduce it to 1/2. We did the same thing just with polynomials. Added them all together, factor the top, factor the bottom, canceled what's the same, and then we had to know what kind of graph this is and put it in the right format to graph. So just go down here, go to -2, up 2/1. That'll give us a graph. All right. And what is missing from the graph right now? RD at -1. So here's -1. open circle. Some people missed that on your quiz. You might have wrote replaceable or removable discontinuity, but then you didn't put the open circle on the graph. It needs to be open. If it's not open, and then it doesn't count. It's got to be an open circle. All right. So in this case, it came out to a straight line. These can come out to rational equations. They come out to quadratics. They can come out to any type of graph. They're not all going to be diagonal lines. So we had a homework like that last week where that was the case as well. See what cancels and see what's left over, and it could be anything that you graph. All right, so let's look at number 2. Same idea. We have 5x minus 1 minus 5x minus 7. Go. And I'm assuming, yeah, these are the same denominator. Didn't have to do anything to get those in order. Tomorrow we'll have to do some extra work before this step so that these are the same. All right, so I'll have, let's see here, 5x minus 5x is 0, right? And -1 and -7 makes 6. Now that doesn't look obvious, right? So because of this minus sign. So it's -1 minus -7. That's what I just did. We got a -1 minus and a -7. And if you do the work off to the side here, well, that's the same thing as -1 plus 7, or 7 minus 1, which is 6. So this is probably one of the most common mistakes when doing these problems. It's not the algebra 1, it's not the algebra 2, it's distributive property, 7th, 8th grade. And if you don't take a lot of space to do these problems, and you'll see on your homework there's not a lot of space, and you try to squeeze it in and write small, that's when this mistake happens. If you do it on another piece of paper, take space, you won't see that as often. So use another piece of paper if it feels like it's not enough room on there. All right, then just go through and finish like the way we normally do. Can we factor the top, or can we factor the bottom? Okay, yeah, bottom factors 2. All right. And since I can see there's a factor of 3 in the bottom, I'm going to rewrite the top as 3 times 2, because that's 6, right? So even though it's just a number, you can still factor it. And then, of course, just like we've been practicing, the 3 divided by 3 equals 1. And then you're left with, what kind of equation is this? What is this called when the fraction's on the bottom? Rational. Very good. So we can rewrite it in the format that we're used to. I'll bring the 2 out front. Horizontal asymptote is 0. There's no number after. So last one, it came out to a straight line. This is a rational, so it doesn't have to be the same type of graph. It just depends on what cancels on the top, what cancels on the bottom, and so on. Okay, how's that look? That's not good. It doesn't look good. Common mistake I saw was it's the number that makes this 0. Remember, this asymptote is when this divides by 0, so -2 is where you want the asymptote. Not at this number, but the number that makes this equal 0 on the bottom. So, there you go. And we have a value of 2, so I'm going to go up 2, right 1, and down 2, left 1. All right. Anything else? Is there any replaceable or removable discontinuity here? So do these count? Is canceling a number the same as canceling with a variable? Yeah, only with a variable will we have this. The value that makes this 0, right? Negative 1 makes this equal to 0, but with a 3, you can't plug in a number to it. It's a number. So, yeah, no open circles needed here. All right, let's look at the homework. Just get a few of these started. Now, if you think you got the hang of it, you can probably try some on your own, but just watch out for that those open circles. Okay, so same as we did before. The first few you might not need a lot of extra room, but you'll find when you get further along that you do. So far, so good. 2x plus 3x is 5x over x. And we have the x's that cancel out. Now, I didn't have an x plus 2 or x minus 2, so my open circle is not at 2, it's negative 2. But what happens if it's just an x? What does that mean? Yeah, well, if it was 1, it would have been x minus 1. Because that makes this equal to 1. So it's not 1. So 0. Yeah, if I plug in a 0, that makes this 0. Seems kind of obvious, but we're so used to having a plus or a minus. So we're going to graph 5. Now, what kind of graph is 5? What kind of straight line? Horizontal. A horizontal line that goes through, remember this is y equals 5, right? So we're going to go through the y-axis at 1, 2, 3, 4, 5. There we go. Someone else said in another period that, well, there's no variable, so you can't graph it or something, or it's a point. No, we can just remember it's the same as y equals 0, x plus 5. Slope is 0 is horizontal. Now, don't forget right here, we need an open circle at 0. Number 2. Now, here you'll notice that these are not the same denominator, but they're very similar. This is just a negative 1 being factored out. So if I take this and I take out a negative 1, that'll leave me with positive x plus 2, which matches here, just by doing a GCF of 1, or negative 1. So I have the first part that does not change, and then on the bottom here, just factor out a negative 1. And if you're not sure, just multiply it back together. Does this times this equal that? And does this times this equal this? And if it does, then you know you're okay. And the goal is, of course, that these two match. We're trying to get these two to match. That's why I knew I needed to do something here. And by looking at this, the only thing I know how to do is a GCF. Yeah. So you can't just multiply the top and bottom. I get 1x. Well, x plus 2 minus negative. If you multiply the top and bottom by negative 1, you'll get the same thing on the bottom, and then this will turn into negative 4. You can. Because either way, you'll have a negative and a negative making a positive, or a negative and a negative making a positive. So yeah, two different ways of doing the exact same thing. Okay. So you'll see the same thing on number 6. If you look down at number 6 real fast, it has a very similar issue where there's a negative that needs to be factored out of the denominator here, and that ends up canceling with the minus sign, the subtraction sign between the two fractions. So really, this is going to be 5 over x plus 2. And what kind of graph is this? Rational. So if you like, you can write it as 5 times 1 over x plus 2 plus 0. And go ahead and graph it. There we go. All right, let's take a look at number 3. Now, here's where you might need to start doing the work on another piece of paper. It's a little crowded, but if you can write small and still be neat and still read it, then you might be okay. But here we go. 5x squared minus 4 plus 4x squared minus 5. Denominators are the same, so 3x minus 3. All right, simplify that top, see what you get. I get 9x squared, negative 4 plus negative 5. Is that negative 1? Negative 9. All right. So you got it down to one fraction. Go ahead and factor and reduce. Factor and reduce. So GCF on the top is 9. That leaves you with x squared minus 1. All over GCF on the bottom is 3. Leaves you with x minus 1. Can I cancel the top and bottom out? Not yet. Yeah, x squared minus 1 and x minus 1 are not the same. You can't say, oh, it's almost the same. Let me just cancel out and leave an x. It does not work that way because you cannot cancel adding and subtracting. You have to make this factored and be multiplication only. So I'm going to write the top as, let's see, 3 times 3 for the 9. Right? And the x squared minus 1 factors to x plus 1 and x minus 1. Did a whole Khan Academy on just those difference of squares. And the bottom is 3 times x minus 1. And then now that's fully factored. Everything's factored, numbers and polynomials. Now you can go through and cancel and see that I got an x minus 1 and an x minus 1 cancel out, which makes the RD equal to 1. I also have a 3 over 3 canceling out equaling 1. So I'm left with a 3 and an x plus 1. So this equals 3 times x plus 1. Now, much like the first example, got to distribute. We got 3x plus 3. Okay, one more to go. Graph this. See, it started at 3, up 3 over 1, down 3 over 1, then go ahead and connect it. Oh, that didn't work. It's not working. There we go. Okay. And don't forget about the open circle here, where we divide by 0 at positive 1. So it should be there at positive 1. All right, lastly for number 4, you'll see what kind of equation do we end up with on the top here. All right, we have a x cubed 9x. We have a minus 2x squared minus 18 all over x minus 2. Now, you'll see that we have an x to the third, we have a 9x, we have an x squared, right? And then we also have this 18. So there are no like terms at all. Nothing's going to add or subtract and combine because these are all different exponents. So we'll put the cube first, but after that we're going to put to the second power, the square, so minus 2x squared. Then we have this negative 9x. And then lastly, we have this 18. All right, I'm just writing these in descending order because that's how we usually factor and work with these. And we had to do synthetic division with them in descending order. Yeah. How's that look? Good? Is it positive 18 or negative 18? Positive, minus. Very good. Again, that's going to be the most common mistake, so that's why I keep on putting it out there so you still look for it. Okay? All over x minus 2. Now, you need to go through. It's x minus 2. Thank you. You need to go through and factor this whole cubic. Hopefully already knowing, well, it's a cubic, so there are 3 factors. And you might have to use synthetic division, right, to find out what those 3 factors are. Now, here's a hint though. There's an x minus 2 on the bottom, right? Chances are there's going to be x minus 2 on the top. So you don't really need to do the plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus, all the factors of 18 plus or minus. You already kind of know, like, well, let's just kind of assume one of the factors is going to be 2, positive 2, right? And do the synthetic division with 2, and that'll give you that'll give you your other factor, and you can actually get through this pretty quick if you already know a number to start on. We didn't have to go through a whole list and plus or minus it and try to figure it out by trial and error. Now, if you know how to factor this a different way, of course, you can use any method. I'm just using this particular one. So bring down the 1. We have 2, 0, negative 18. And we're left with, remember this is negative 9, 0x, x squared. So we're left with x squared minus 9, which factors to x plus 3 and x minus 3. Yep. So lastly, we can cancel out x minus 2 over x minus 2, which means the RD is at x equals 2. Now, what kind of graph is this? What kind of graph? That's a parabola. So we know the roots are going to be at negative 3 and 3. So negative 3 and 3. And the y-intercept is negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, way down here. Kind of goes off the graph, but yeah, so we can get on this one a parabola. So the graphs can be straight lines, horizontal lines, diagonal lines. It can be the rational equations. It can be a quadratic. right? We can have any type of graph here. All right. Now, is that finished? No, what's missing? RD is at 2. So don't forget that open circle at 2. Pretty much all of these will have a open circle or an asymptote, like on the rationals. The asymptotes here, that's the same thing. It's when you divide by 0. They're just all over the place. That's why it's this vertical line. All right, so most of it's review, but if you haven't kept current on your homework, it's going to seem like an awful lot, but it's definitely doable for most. If you need help, just come in after school, before our school, and we can get you caught up.